Okay. So, hello everyone. I hope you are able to hear me. And I'm Ali Mustafa, and today I will be your host. So, let me share my screen and let's get started. Okay. So, about me, first of all, welcome everyone. And I tried to use Google Translate and tried to convert this in as many languages as I could, as many Indian languages as I could. So, if I did some mistake, you can blame Google Translate. But yeah, I tried my best. So, welcome everyone. A warm welcome to day three. And today we are going to talk about TFO production. So, about myself, I build human networks, not the computer ones because they are crazy and I also don't like them. And I'm the organizer of TFUG Mumbai. I'll share some of the glimpses about TFUGs in India when we started back in around 2017 and 2018. So, I talk a lot and I will take a full 10 minutes mostly. And I'll talk about the journey of TFUGs in India and specifically how we got started and how big we are today. Let me just zoom in quickly. Okay. So we started TFUG in India. So not as a TensorFlow user group, we started as a TensorFlow group, and it was a just an Facebook page, and we used to do some events here and there, once in a while, once in 3 months, once in 4 months. And it was not a centralized process, but I thought that we use TensorFlow a lot, and I used to teach a lot of students TensorFlow. So there was not an offline community, so I wanted to start a community, and that's why I started a page as of 2018. And there were some TFUG user groups abroad, not in India, and that's why I decided to kind of approach the global team of TensorFlow to get some support. And in 2019, in mid 2019, we became official. We were listed as the first TensorFlow user group in India on the tensorflow.org/user group website. And after that, we started receiving support from Sun Sun and Eric. And soon after, we renamed ourselves as TFUG Mumbai, and there was then TFUG Bangalore, and we became 14 of them. And that's how a single page of Facebook got converted into a big community of 14 chapters across India in different cities. To just show you a glimpse of what we used to do earlier. So this was one event in 2019. It was TensorFlow all around, supported by Sunsun and Eric, and we did that event in around, I guess, 5 to 6 cities in India, totally driven by community members, and we received support from I guess Korea and all the T-shirts and everything. So at that moment, it was because we were growing massively, and it was very difficult to fetch support from again and again Sunsun and Eric. So I guess they formed a team in India, and that's how new TFUGs were born, and that's how new TFUGs started. And the the one takeaway which I want to a very key takeaway which I want to take which I want you to take away from this address is that if you are looking forward to start something and you feel that that is not existent enough, there is no support as of now when you start it. Okay, it is a global entity, but you don't have support as an individual level. Start it. Okay, because once you start it, people will notice it, people will kind of give you support. Once when I started, I guess back in 2018, I didn't had any support, so I contacted many mentors. Sayak was one of them. So I contacted Sayak. I was like, Sayak, would you like to mentor us? And we have started a group. Would you like to help us out? And he extended full support, and that's why we have grown so much. And like Sayak, there were other mentors as well who helped us from Delhi, from Bangalore, and so many different cities. And that's how we started as a small Facebook page. But today we are at so many different places, doing so many wonderful events. And one of the massive events which we are doing right now, which you are attending, that is TFUG India Summit. Another thing which I want you to tell you is, don't worry about other things when you start something. Okay, and other things will follow, and they will be in place. So as soon as you start something, you will get the support, you will get the recognition that you need, that your group needs, and you just need to keep it open for everyone. You need to make sure that others also join in and they contribute, and that's how you make a successful community. So yeah, that's a very small address about TFUGs in India. And when I started, I only had one person with me, that was Nawazuddin, and he is now in Australia. But we started because we were doing a lot of TensorFlow meetups and workshops for the crowdsource community. And from that, we thought to start a new community for TensorFlow, and that's how the first page originated. So yeah, start small, keep contributing, invite others, and that's how you can make another community. If you want to join a TFUG community in your city, you can go to the official TensorFlow site, or the we will post all the links in the comments, and you can go and select and join your user group which is near to you, near to your city. If you don't have a user group in your city, in that case, you can apply and make a new user group in your city. So don't be afraid to start and shoot. All the links will be provided to you in the comments, and then you can shoot an email, and then you can start your TFUG. So yeah, that's all from my address. Thank you so much for attending, and I would like to invite Sayak to introduce to you our very first speaker. Today the theme is TensorFlow for production, and we are going to talk about how you can use TensorFlow in a live setting. So I invite Sayak to take over and introduce our very first speaker.
Well, I'm back again. Thanks, Ali, for the lovely opening note. As Ali mentioned, welcome to TFUG India Summit Day 3. Today, we'll be having the track on TensorFlow for production. We have got an amazing lineup of speakers, as always. We'll be having a diverse set of speakers today, and of course, the topics will be diverse, including TensorFlow for extended, Kubeflow, Kubernetes, fairness in machine learning, and so on. Our very first speaker is Robert Crow. Robert is a developer advocate on the TensorFlow team for Google. He more precisely, he is on the TensorFlow extended team. So Robert is extremely passionate about helping developers in getting started with TensorFlow extended and understanding their needs, their pain points of using TensorFlow extended. So let's hear it out from him. Robert, why don't you take it away?
Hi. Well, good morning for me, or good afternoon for you. Let's go ahead and get started. I need to share my screen here. Okay. I hope you can see my screen because I can't see you.
Yes, Robert, your screen is visible.
Okay, good. So we're going to be talking about ML engineering today for production ML deployments, and that's going to use TensorFlow Extended, or TFX as it's better known. So first, let's talk about what production ML is and how it's different from just, other normal ML. There's different kinds of problems that we try to solve, and we discover that change is a key component when you put something into production. So easy problems like recognizing cats and dogs, they don't change very much. It takes them a long time to change. So those are fairly easy problems to try to put into production and maintain over a long period of time. It gets a little bit more challenging when the ground truth in the domains that you work in changes, on a fairly frequent basis. So an example of that is styles. If you're working in, say, clothing, styles change fairly quickly, certainly from season to season and from year to year. So what that means is you need to retrain your model on a fairly frequent basis so that it continues to perform well. And when it really gets challenging is when your ground truth changes very fast, or the data that you're using changes fast. Now, there's always reasons to retrain a model to try to improve performance if you're getting different data, in other words, different features, or you have a different model architecture that works better. But when your ground truth changes, you're driven by the need to change just to stay up with the latest ground truth and have your model perform well. So that was the reason that Google developed TensorFlow Extended, TFX. TFX is used all over Google, and that's why we developed it, because we have a ton of machine learning in production for all of the different products that you see from Google. So we needed a good, strong platform, and we created TFX to be that, and that's what it is at Google. It's also used by a lot of our partners, and you'll recognize some names here, and there's a long list of others. One of which is Twitter, and Twitter has an interesting case because they actually came from a torch-based environment that they made a lot of investment in. And they stopped and looked at where they were going in the future, did an evaluation, including PyTorch, and ended up adopting TensorFlow for their systems, largely because of the TensorFlow ecosystem, including TFX. This is kind of a high-level conceptual diagram of TFX. On the top, you see the tasks that you perform. So starting on the left, you ingest data, and you move through model training and eventually serve a model. In the middle, you see libraries. So these libraries are available by themselves, and TFX integrates them into an ML pipeline. So the components here in orange on the bottom, those are the TFX components, and we're going to be talking about those quite a bit. They use the libraries, they leverage the code in the libraries to do what they need to do. So different components that are doing different things leverage different libraries. And at the end of the day, this is the pipeline, or directed acyclic graph, or DAG, that is kind of you can think of this as sort of the hello world of TFX. This is what you start with a basic example. And we'll go through each of these components and the deployment targets here on the left. But this is what it looks like. So first, let's talk about what a TFX component is. A component does a task. It has a configuration. Of course, it has the code for the component, and it takes input from metadata, except for the very first one that ingests it from some data source. It does that over an input channel, which is an abstraction that you'll see when you create custom components. And then it does whatever it's going to do and writes the output back into metadata over an output channel. So that's the basic flow of a single component. Components communicate with each other through metadata and through dependencies. So an upstream component will generate a result, it'll put it into metadata. A downstream component that depends on that result will pull that artifact from metadata, do what it's going to do, and then write its result into metadata, and so forth. And that's how data flows through the pipeline. So we've talked a couple of times about the metadata store. Let's talk about what that is. So the metadata store is it's a data store that saves metadata artifacts. So one of the things that we do is we keep a lineage of those artifacts, which components generated them and which components consumed them. So that one of the things that this enables is allowing you to find out which data set a model was trained on. Remember, so data sets and models can live in metadata for months or years. So if you're going back a couple of months and trying to find the data set, normally that could be a challenge. This also allows you to compare training runs between model training runs over a fairly long period of time, as long as you have that in metadata. So here's an example in TensorBoard. We could be comparing a model that we trained 6 months ago with a model that we trained just now. We also want to reuse previously computed outputs if at all possible. TFX is designed to work with large compute loads and large data sets. So if the input to a component has not changed, we don't want to rerun that component, which could take hours or even days. We want to just pull that previously calculated result from metadata, because it won't have changed. The input is the same, the result is going to be the same. A lot of this leverages a distributed pipeline for distributed processing on clusters. And the framework that we use for that is Apache Beam. Apache Beam runs on a number of different underlying compute frameworks. So Cloud Dataflow certainly is one of those, but also Apache Flink and Apache Spark, and Apache Samsa is another fairly new one. And what Beam does is it provides an abstraction layer on top of those frameworks. It also provides SDKs in a number of different languages. So we're using the Python SDK with TFX, but it's also available with other languages that you could use, for example, in a container component. In the middle, you have Beam. So a component, when it wants to produce a result using Apache Beam, will translate its task into a Beam pipeline using the Beam abstractions and operators, such as sum per key. That'll be a P collection for the data, and the operations it performs will be expressed as P transforms. Those are then sent out to and translated into the native abstractions for the target framework, which does its task and then produces a result. So that's how the component receives the result back from the compute cluster using Apache Beam. There's a number of standard components that come with TFX, and we'll talk about them fairly quickly since this is a pretty short talk. So again, this is what our kind of hello world example looks like. And starting on the left, we have example gen. There's a number of different example gens for different types of data source, but they all share the same task. They're going to ingest data from the data source and split it. The default splits are just train and eval, but you can define as many splits as you need. Then we have statistics gen, which takes the data set from example gen and calculates summary statistics across it. So things like the mean and median and standard deviation, but also looking at categorical variables to see what the valid values for those categories are. Then we have schema gen. Schema gen looks at your data and tries to infer the schema of your data set, the data types of each of your features. And it makes the best effort at that, but you do want to review that schema and make sure that it's correct. Both the statistics and the schema are used by Example Validator to look for problems with your data. So things like missing values or categorical variables with values that shouldn't be there, that sort of thing, or values that are the wrong type, say a float where your feature should be an integer. Then we have transform. Transform is where we do our feature engineering, which, as you probably know, could be fairly complicated. Transform has the special property that the feature engineering that you do, and this is going to leverage the TensorFlow Transform library, those feature engineering operations are going to be expressed as a TensorFlow graph. That graph is then passed to trainer, and that's going to be used as the input graph for your model. So once you've trained that model, wherever you deploy it, you're going to be doing the same feature engineering on your data. What that does is it avoids training serving skew. Trainer itself is going to use TensorFlow to train your model. And there's a number of different ways to do that, including in cloud AI training. So trainer, there's a couple of different types of trainers. Evaluator does a deep analysis of the performance of your model. And by deep analysis, what I mean is you set up a criteria and you do slices of your data. And those slices need to make sense for your particular domain. So going back to our style example, if you're working in clothing, you may have different slices for different types of clothing, say men's clothing versus women's clothing, or clothing of different sizes, what have you. Whatever slices make sense, you want to make sure that your model performs well, not just over your entire data set, but in each part of your data set, in each slice of your data, because each of those represents different users for your model. Evaluator also compares your model with the model that you currently have in production, if you have one. And it wants to make sure that your new model performs better than the one that you already have. Infravalidator checks to make sure that your model can actually be deployed to the inference systems that you have. Because you might have had the situation, for example, where you're trying to run a model and you don't have enough memory. So things like that you want to avoid before you deploy that model to a production environment. If the model passes both evaluator and infravalidator, then Pusher will push it to your deployment targets. And those deployment targets could be any of a number of different things. So they could be, for example, a serving cluster with TensorFlow Serving, or a mobile application with TensorFlow Lite, or a JavaScript application, say in a web browser or a Node.js environment. Or you may just be saving that model in a repository like TensorFlow Hub and using it later to generate embeddings or to do transfer learning. One of the newer aspects of TFX is that we have better support now for mobile and IoT with TF Lite. So the way those work is that when you train and evaluate your data and deploy it to TFX Lite, or TF Lite rather, using TFX, you're going to do that slightly differently. So you'll train and deploy normal saved models, but you will use the TF Lite rewriter within trainer. And when you do the evaluation, it'll evaluate it as a TF Lite model. One of the things that TFX allows you to do is to create custom components, because we just looked at the standard components that you start with, but in most cases, you will need more than just that. You'll need components that are specific to your particular environment or problem or data set. So to do that, there's a number of different ways. But essentially, the first one is to extend existing components by writing a custom executor and just replacing the executor of an existing component. When you create any custom component within TFX, it plugs into your pipeline exactly the same way as any other component. So here you see there's a custom component that's just fitted into your pipeline. There's really nothing special about that. So there's three ways to create a custom component. The easiest way is just using a Python function and decorating it and adding some annotations in the signature. That is a very easy way to create a custom component. You can also, if you need more capabilities, create a container, which could be running any language that you need, and then wrap that container as a component and use it in a Docker-based environment, for example, on Kubernetes. And you can also do what we started with, where you're extending an existing component by creating a new executor. Or for that matter, you could create an entirely new custom component. Cloud AI Pipelines is one of the environments that you can run TFX in, along with running it in just a dedicated system or on your laptop. And we'll look in a second at 3 different ways to run TFX. At a high level, this is what Cloud AI Pipelines looks like. So you have TensorFlow, and TFX is running on that. It's then running on top of Kubeflow pipelines, which in turn is running on GKE, Google Kubernetes Engine. And through the Google Cloud, we're leveraging
Kubernetes is an open source container orchestration system for automating computer
Sorry, my
application
phone
deployment,
just
scaling, and management.
heard me. It's leveraging the cloud services like GCS and BigQuery and Dataflow. At the end of the day, well, on Cloud AI Pipelines, you end up with the same pipeline. It's still a TFX pipeline. It's still running in a DAG. You're using the same components. It's just running on cloud. All right, so we have a quick demo, and it's very quick because I only have 15 minutes. So what I did is record it as a video so that I could make sure to get the timing right. What we're going to look at is 3 ways to develop and run in a TFX pipeline. So first we'll look at TFX, just an entire pipeline running in a notebook on Colab. And then we'll look at running TFX on your laptop to do development there. And then we'll look at running TFX in the cloud. Okay. So I need to stop sharing. And I'm going to actually let me do this. Yeah. Actually, let me do that a little differently. Sorry. Okay. In the demo today, I want to show you 3 ways of developing with TFX. And to start with, we'll just create a complete TFX pipeline in a notebook. I hope you're hearing the sound. And we won't actually get through the entire pipeline, but we'll get through the first few components, and the rest are very similar. So let's get started. I'm going to just jump over the explanation. This notebook, by the way, is available on the tutorials page of the TFX website. I've already run this once, so these. I'm just going to stop for a second. I want to make sure you're hearing the sound. Yeah. Hello?
The sound is clear, Robert. You can continue.
Okay. They're preloaded so that we can save some time. Okay. Normally on the first run for this, you need to restart the runtime because of the way that Colab loads packages. So now we're going to import our packages. Okay. Let's check the versions, make sure they're good. This is actually version 22. We just released version 23 this week. Set up the paths, and this is the Chicago taxi example. Okay, we've got path to our data. That's what the data looks like. This is a CSV file. And now we're going to create the interactive context. So the interactive context is a key part of running in a notebook. Essentially what this does is it allows you to orchestrate a pipeline by stepping through notebook cells, and the interactive context maintains the context while you're doing that. So very useful for this kind of development. All right, and now we're going to run our first component, which is example gen. That's where we're going to ingest our data and split it. Okay, now at the end of each component, after you run each component, you'll see one of these. It's the Artifact Explorer, and it lets you explore the artifacts that were imported into the component and the resulting output from the component. So this is example gen, and I can look at the inputs that came through this input channel. And in this case, it's a external artifact. It's that CSV file, and the outputs. So the outputs are our split data set, and there's our split. We have train and eval by default. Okay, let's keep going. So now we're going to just take a look at the artifacts in a different way. That's just more of a Pythonic way to look at it. And we can look at individual examples that were ingested, and they look good. And so we're going to run our second component, which is statistics gen. Statistics gen is going to calculate statistics across our data set. We get, again, an artifact explorer for statistics gen, but let's keep going because there's a really nice UI for statistics gen that comes out of TensorFlow Data Validation, TFDV. And it allows us to really explore the statistics around our data set and our different features, including looking for the number of missing values and things like the valid categorical features. So really useful to be able to explore your data set. We're in the part of the ML development process here where we're really trying to set up our data and understand our data set. So let's move to the next one, which is schema gen. Schema gen tries to infer a schema from your data set. What are the types of your features? Now, you do need to think about making sure that you got it correct because it'll make a best effort at doing that. But you may know more than schema gen does. So if things need to be adjusted, you can do that in the artifact that's produced by schema gen. Okay, we're going to stop there and move to the next style of development. Okay, the next environment we're going to look at is running locally on a desktop or a virtual desktop. We're going to be using Jupyter Lab with a notebook, and we're going to be using an IDE. So to start with, I've copied the Beam template into a folder on my system and started up Jupyter Notebook, which is open here. And let's go ahead and run through the notebook, at least the beginnings of it. One thing to be careful about, since I'm not running in Colab, I already have TFX installed in my virtual environment, so I'm not going to run this cell here. So we'll go ahead and set up some paths, check our version of TFX, which we've already installed previously, and set up some other variables and check our pipeline name and project directory. And then at this point, we're going to copy the rest of the template, the other template files, into our project directory. And we're using the TFX CLI to do that. So we'll go ahead and do that. And you'll see that I don't have CUDA loaded. So we see some errors around CUDA. That's fine. It's just telling me that I don't have CUDA. And then in the notebook context, we change into that directory. And then we can browse the files as sort of a sanity check and run some unit tests on our files too, which is always a good idea. Okay. So we copied our template into the project directory. Now we're going to create a pipeline for the Beam DAG runner to run. Now we're not running it yet, we're just creating it. Okay. So actually it's telling me it already exists because I ran this once before. So now we're going to run our pipeline. So again, using the TFX CLI here, see that right here, and we're using a run command. So at this point, the only component we have in our pipeline is the example gen, which is in this case reading from a CSV, and you can see it's finished. Okay, so now let's move on. And we'll add some components. So to do that, we can do it a couple of different ways, but I'm going to go into an IDE. I've got VS Code running here, and these are the files we're working with. This is actually the template that we're running in Jupyter Lab. So I could be running all of this in VS Code too. But where I want to add those templates, those components, is in my pipeline file. So I'm going to edit pipeline.py. And you'll see the way this is structured, it's really easy to create this first sort of hello world pipeline using the Chicago taxi example. Example gen is already part of the pipeline. Statistics gen is defined, but it has been added to the pipeline. So all I have to do is uncomment that to add statistics gen. And let's add a couple more. Let's add schema gen and example validator. And let's add transform because we want to do something here with transform. So I'm going to save that file. And in transform, there's some user code that we're going to be using, and this is where we do our feature engineering. So there is a function in our preprocessing.py file called preprocessing function that's given to the transform component, and transform runs that to do preprocessing or feature engineering on our data set. So what I'm going to do here is set a breakpoint there, and then I'm going to run the Beam DAG runner here. So I'm going to go to the debugger, and I'm going to start up the Beam DAG runner. No, I'm sorry, wait. I have to update the pipeline first. So this command right here, I'm going to run. And in fact, I'm going to comment out the run command so that I'm only doing the update. Otherwise, it would run it twice, and that's fine, but I don't want to do that. So we'll go ahead and run that. It'll update the pipeline for me, so it's going to add the components that I just added, which are statistics gen, schema gen, example validator, and transform. Okay. So now, if I run the Beam DAG runner in the debugger, it's going to run my pipeline. And it's going to hit an error that I caused when I edited the file, which is okay. So that's all right. We'll stop that. We'll edit our file. And it was complaining about one of these here. Oh, I need to edit pipeline.py because that's where, yeah, I got an S from just bad typing. So let's save that and we'll rerun Beam DAG runner. And there we go. We hit our breakpoint. And we have variables here that we can inspect, including our features. So for doing IDE style development, you could actually do it in a notebook or the IDE or both. This is pretty handy. Okay, the next style of development that we're going to look at is on Google Cloud, where we're using Cloud AI Platform pipelines to run a TFX pipeline. And this is running actually on top of Kubeflow pipelines. So you have, in this case, a Jupyter Lab. Very similar to the template we just looked at with the Beam orchestrator. Not like the interactive context we looked at first, but the Beam orchestrator, where we're setting up our components and then we run our pipeline. So very similar. We're using the CLI down here to first create our pipeline, and then when we make changes to our pipelines, we kick off an update and then a run using the CLI. So very similar process. And again, you have the same sorts of files. They're here in my project directory. So the pre-processing function is just like we looked at just now in Beam, although I can't set breakpoints in Jupyter Lab. And I add and subtract components here in pipeline.py, just like we did previously. So we have that environment, and we also have Kubeflow pipelines. So this is the notebook that we're using. That's the template that we just looked at. We can also look at our pipelines in a graphical view to see how things are put together. And we can also look at experiments in very much the same way. So there's an experiment that we've run, and you'll see it's been marked as successful. We also have artifacts that we can look at, and there's a nice tool here that allows us to look at the lineage of artifacts and understand how they flow, how the data flows through our pipeline. So a lot of great tools here on Google Cloud. I encourage you all to look at it. I know this was really fast, but hopefully this was useful. Thanks very much. All right. So there we go. That's TFX. Just to kind of review that demo a little bit, we started out doing a TFX pipeline in a notebook. We were running on Colab, didn't have to be Colab. And we're using the interactive context as our orchestrator. In the next part of it, we were running on a desktop. We were using a Beam DAG runner as the orchestrator. Beam is normally used as a distributed pipeline, but we can also use it as kind of a special situation as an orchestrator. And it's really handy for doing that kind of development. And in the third part of the demo, we were looking at very similar style of development, but on Google Cloud with Cloud AI platform pipelines. All right. So that's all I had. And yeah, I guess if there were any questions, we could take a question. Hi, Sayak.
Hey, hi, Robert. Thanks for delivering such an amazing session. I guess it was just introductory enough to get folks excited about MLOps and TFX in general. So we have our first question from Vipul. He asks, we are talking about pipeline being a DAG. I used to read that process is iterative, not linear. So how does updating only a part of the model work with this pipeline?
So the pipeline and the DAG are more than just a model. The model itself is that's trained in trainer. And remember what the pipeline is used for. It's used for training a model. So the model itself is defined in TensorFlow, and it is its own object, if you want to think of it that way. The operations in the pipeline that flow through the DAG are things like ingesting data and doing feature engineering and then evaluating the model and so forth. So the model really is isolated to the one, well, at least the basic scenario model is isolated to trainer alone. The reason I pause is because you could actually use a previously trained model in Transform to do, say, embeddings or something. But I hope that answered the question.
Yeah, I hope so too. So we have one more question from Rishit. He asks, could I use Apache Beam to perform a custom window merging while using streaming execution?
Yes, you could. Apache Beam does some fairly good windowing in a couple of different ways. There's fixed windows and sliding windows. There's also session-based windows where if you're working with data where you need to look at a session and keep it together. So yeah, Apache Beam is great for that. That will be there's going to be a blog post that's coming out that looks at a real-time scenario doing streaming. So look for that, and there's a great example that comes with that as well.
Thanks, Robert. That's all we have for the questions. So one final note, just I wanted to give all of our participants, if they were to get started in TFX or machine learning pipelines in general, what would be your suggested resources?
Well, I would start with the TFX website. There's the TFX user guide there that goes through a lot of the details of how TFX works and how to get started. And there's a number of different tutorials, including the one that we looked at the beginning of the demo. So that's a great way to get started, and you don't even have to install anything on your system. You could run in Colab for several of our tutorials. So that's a great way to get started. Okay. There's also, I should say, there's a new book on TFX. If you from O'Reilly, if you want to go take a look at that, it's a great book. It's from Hannes and Catherine, who are some great writers that we talk to a lot.
Yeah, that's what I was gonna coming to. I mean, I was gonna ask you, is there a book or is there a course? So yeah, you got me there. So again, thank you, Robert, for joining us today. I guess that's it from your end, and we look forward to hosting you again.
All right. Thanks very much.
Yeah. Thank you. Okay. That's it for Robert's session, folks. I know we are running a little bit behind the time, but that's all good. I mean, every show has some hiccups, right? So from here, I would like to hand it off to Ali, who will be introducing our next speakers. And yeah, let's hear it out from them.
Hello, everyone. I hope you're doing good, and the session was good enough, and I hope you get started with TFX soon. So our next session is on the topic ML engineering for production ML deployments. And for that, we have two speakers actually. They'll be sharing the stage together. And the first speaker is Sharmi. Sharmi is a machine learning engineer, Google developer, experts in ML, an international tech speaker, and an amateur blogger. She has worked in the pipeline of the Smart Cities mission of India at Indian Space Research Organization or ISRO. At the present, she is building the next generation document agent to automate the data entry and paperwork involved in global supply chains for gigabytes unstructured data at shipments.com. Our next speaker is Sharmista. Sorry if I pronounced that wrong. Sharmista is currently working as a senior manager of data sciences at Publicis Sapient. She is responsible for driving digital transformations of clients using AI/ML across a range of industries, including travel, hospitality, supply chain, IoT, media, amongst others. She has proven experience in both doing AI research and implementing scalable AI solutions for enterprises. She is a professional cloud architect and also a Google developer expert in machine learning. So I welcome both of you. The stage is all yours.
Hello, Ali. Thanks a lot for the kind introduction. So, let's start with our session on fairness in machine learning. In today's session, we are gonna learn that what the fairness in machine learning means, what are the terminologies such as bias, which creep our systems, and how to mitigate such biases to have a fair system and a whole ML modeling pipeline. In the later half of this session, Sarmishta would share her insights on a live project which she has built using TensorFlow and how we will get to know from her that how we can develop a fair model pipeline. To start with, let's first of all do an eye test. Let me know in the comment box that what do you see in this picture? Okay, so I'm getting some answers like, hey, these are bananas on shelves, bananas which are in the shop or a mall and they are having stickers. Perfect. Let's move on to the next picture. What do you see now? Green bananas or unripe bananas? And now, if we move on to our next picture, we are tend to say that, hey, these are brown bananas or over-ripened bananas or bananas which we are not able to eat now. So let us just now throw them away or make a smoothie or bread out of it maybe. Let's do retrospection. What just we did? When I show you the first image, the first picture of yellow bananas, in our mind, we thought that, hey, these are just bananas. We didn't mention yellow color explicitly. Why? Because it just goes without saying. From childhood, the image of banana, which we have learned and saved our minds, are so like a yellow color. It's very typical and ordinary. And all the other shades of banana are out of ordinary or less typical, right? If I give you another example, all of you right now visualize how a rose looks like. Did any one of you imagine rose of an orange color having a gradient similar to TensorFlow logo? I don't think so. Most of us would have imagined a red color rose, or in a worst case, maybe pink or white. And now, if I ask you to imagine a pizza, would you ever imagine a pizza which is a square shaped or a rectangle? Mostly not. We would imagine a slice of a pizza which is of a triangular shape or a round shaped pizza because these things are out of ordinary. Thus, When we separate different objects and different things based on their shapes, colors, sizes, that is the cognitive blind spot we have in our mind. And that is exactly what is known as bias. We are giving some much more importance to one object as compared to others. So now, in machine learning, what does fairness means? This is exactly the same when we differentiate between different objects based on their gender, maybe your ethnicity, sexual orientation, disability, and whatnot. But does fairness affect ML models? Let's see. This is in general ML pipeline that first of all what we do, we collect the data, we label the data, then we choose the perfect hyperparameters and features to train our model, and then we check it on different accuracy metrics, and finally we deploy that so that our end users can use that system and get benefited out of it. Can bias affect this pure ML pipeline? Yes, it can. There can be human biases present in each and every phases of this pipeline, starting from collecting data to the end user, how they perceive the result. The bias is present. And now let's discuss what are the different kinds of biases which can be present in any ML system. The first one is reporting bias. Imagine that you are filling a survey of how did you feel about the TFUG India Summit, or the latest font which you bought, or the latest book which you read. If that book you liked, if that phone that you liked, or if the TFUG India Summit you liked, there are less chances that you would comment over a public survey or a personal survey. Versus if you hated that phone or you hated that book, there are high chances that you would fill up the survey. So the database gathered out of this service would have an imbalanced classes of these comments. Most of the comments would be hatred, or some of the comments would be out of so much of love and respect that they just love the summit or they just love the phone. That's why they are commenting. But most of the comments which are neutral won't be present in the data set. And that's why, because of having this imbalance in our data set, the output which our ML model will generate would be biased. And that is known as reporting bias. The next one is automation bias. When we nowadays we are seeing that our life is mostly around AI, and AI, there is no field where AI has not put its step into, starting from education to law, healthcare, and so on. But when now we are relying so much on this ML models, and then sometimes if we think that these results or these outcomes which are generated by an AI system are much more have much more chances of accuracy than a non-automation system or a human, that is known as automation bias. The next one is selection bias, which has subcategories like coercion bias and non-responsive bias. It happens that when the group which we have selected does not represent the whole class and whole group on which it should have been gather the data. So the data which we have is not representative of the whole real world. There are much more of such examples like group attribution bias. Imagine when you are building a resume screening application using machine learning, and there are two different people who think that from the university they have graduated, or let's say if they have a MTech or PhD degree, then and then only that candidate should be selected for the next interview round. These biases are based on the personal mental biases. Some people think that having this feature is must with respect to someone else, which thinks that this feature is must. So having this correlation of mental biases in ML model is known as group attribution bias. Implicit bias. What does this sign means? If you are in India or US, it would say that this is an okay sign. If you are going to Japan and do the same sign, they would say that this is a sign of a money. And countries like Brazil, this is an offensive sign. Also, the thumbs up which we do, or the first rank sign which we do, different countries have different notions of this sign. The victory in some of the countries is a very offensive sign in some other countries. These biases, which are different with respect to different geography and different person, is known as implicit bias. And there are many, many more biases which can affect the output of ML model. Okay, we understood that there are biases which can affect, but still, do we have ever seen any side effects on real life projects? Have we ever seen that this kind of things are affecting our results or our search results? The answer is yes. Go and try out this by yourself. When in Hindi, in Google Translator, you type that wo doctor hai and wo nurse hai, the Google Translator would translate that doctor means a muscular, a male gender, and nurse, it matches it with a female version. So he translates, Google Translator translates this to, he is a doctor and she is a nurse. What can be the possible reasons? Imbalanced data that they have, the data set which they might have used for creating such applications had the bias, or most of the sentences in those data set were maybe can be of nurse representing to a female gender and then doctor who are male. Some of the images which have a model which has trained on wedding images on white people. So when you now test this model on the images of Asian people or black people, the output is fairly different. When you put in images of white people wearing white gown and suit, it remembers and it recognizes that this is something related to ceremony, wedding, there are bride and groom, etc. Versus here, the output is that just in this image they are person, nothing else. Thus, starting from our online shopping which we does, and then we get recommendations, or on online movie recommendation systems or movie streaming platforms when we get recommendation, or when we go to some of the medical hospitals or shops, and then we get such kind of biases. The thing is that we are relying on AI so much, and it has seen side effects and various domains, starting with healthcare. When your model is being trained on data which is of white people, and then when you test it on the black or Asian people, there are chances that it has the solely different kind of results for both of them. That is known as the racial bias. For hiring, in a company called Xiang, or the same effect has even been shown in Amazon in year 2018, when they developed a hiring platform based on AI, which can select some of the candidates which can be beneficial for a country to maybe interview. There are more number of male candidates which got selected as compared to female, even if the female had similar kind of backgrounds, or maybe in some of the cases they were much more experienced. As in this image, you can see that work experience of the ranking first candidate was 146, versus this model has ranked someone who was female having ranked 10th, but she had experience of more than the candidate ranked 1, and all of the features were also higher. Still, we show this bias and difference in the results. In finance, there is a case study done by PwC when they developed a system that can credit the score to their customers, that how much they have connected with the company beforehand and how much credit they should give. There was bias based on their location, their geography, and their past background. In law, in United States, model named Compass is now being used in some of the cases to help judicial system. AI-based model is now predicting whether the person should be offended or not, whether he should or she should get punishment or not. And here is the result, what that model thought. African American people had almost 2 times more chances to get offended by that system. In educational based system are now being biased based on the colleges the student is from, or the income that person has, or from the geography they belong to. Even in fashion now, we have seen various AI based systems being biased. We are in the 21st century, and we know that real beauty is from inside and not is connected with the shape or color or size. But now AI systems are contradicting this wave we have created of inner beauty, and they are giving us results in terms of enhancements. So whenever you used an AI powered enhancement application, there are high chances that it will convert your Asian photo or dark skinned photo into a white skinned photo. That system would, in terms of enhancement, would try to reduce your shape of the body. So these are the different biases we have seen in the past few years in different domains. And most of them are because of the data which we have gathered, and then the model is learning from that only. Some of them are just because we have neglected them to take care. In United States, the female body type crash tests were not even being done, and as a result, the female drivers had high chances of being injured during an accident. We have developed some of the products which are respect to one kind of race, one kind of sexuality, or one kind of a gender. But we should build products and technologies that just works for everyone, irrespective of such biases. With this note, I would like to hand over to Sarnishta on how we can inherently encode and embed such things into our ML model, and then how we can mitigate the biases in AI system. Over to you, Sarnishta.
Sharmishta, you are muted. Can you please unmute? Yeah, on the right hand side, you can see the unmute button. Unmute. You have to do it yourself.
Yeah.
There is
Yeah.
okay.
Hope you can see my screen. Is my screen visible? Hello. Yeah. So you can see that how we can build a fair system. Charmi has given a wonderful introduction to how we can build why we should remove bias and why we should build fair systems. But you should never trust the speaker. You should always ask them to show the codes. So let's go into deep dive some of the deep learning models to see how we can incorporate fairness into those models. With that, we show you that a data set which we have taken from Kaggle, and that data set is of Jigsaw unintended bias in toxicity classification. So there are many jargons here. Let me go through one of them one by one. So it is data collected from AI conversational agents, which is kind of a wiki document for different types of text, including textual data of mental illness, physical illness, the economic condition of the people, including race, gender, sexual orientation, as well as religion and the country. So each of these different subjects have very limited data or terms related to sexuality or gender or this economic, social, or health conditions. Now we have taken the data and split it in terms of three different parts. So the first is the training data set, next is the validation, and next is the test data set. And how we see that, how do we build a fair model, what is the context? So each of these different contexts, you will see that very limited terms like male, female in the gender, or like homo, will be very limited in the context of that subject. So we have to identify the sensitive topics which are very present in very limited numbers in each of these groups, and we call them as subgroups, and we have to predict them correctly. And how do we do so? Let's see that. So we would use TensorFlow constraint optimization, and which would allow us to use different optimization techniques. So we can add our optimization based on only false positives or false negatives, or constraint on both false positives and false negatives. And how we do that, we have to first import the TensorFlow related basic packages like the TensorFlow, the Keras, the layers. If you are doing textual classification, we need to use sequence, text, and then we import the TensorFlow constraint optimization library. Then we have, because we are going to build a deep neural network, we need to import all the models related parameters from the TensorFlow Keras packages. So this includes in model input, dense, embedding, or global max pooling, global average max pooling, bidirectional, and dropout, and convolutional LSTM. So after we import this necessary packages, what we have to do, we have to implement an optimizer, a rate min-max optimizer that is able to optimize the non-convex problem, where we will set up that we want our constraint is only on the number of false positives, or is it on both. And TensorFlow, thanks to TensorFlow and Google, that it has implemented the proxy Lagrangian optimizer. Why is it that only Lagrangian optimizers have been found to solve constraints, but they are not so stable in case of stochastic gradient descent classifiers? But here, proxy Lagrangian optimizer, which has been developed, is able to handle large amount of data sets with non-convex and non-differentiable constraints, and they are able to converge to the multiple stochastic gradient classifiers and give a fair amount of result. What do I mean by a fair amount of result? So it can classify into M+1 deterministic solutions, and it will give a decent output in terms of the constraints, the input wherever we put the constraints. And what is this current limitation of the TensorFlow constraint optimizer? It is does not support multi-class till now. So TensorFlow team is working on it, and we hope to get the multi-class classification soon. And here you see that how do we implement the constraint. So here is the subgroup. So I have taken mental illness as one of the groups. Like we have talked about economic condition, physical health condition, the social condition, race, gender, so many things. Now I take only the mental conditions of the people. So I try to put it into different subgroups like depression, anxiety, bipolar, or autism, and schizophrenia, and so others. And now we try to find out what is the subgroup proportion for each of these groups, subgroups which are present, and among the entire data set, this is the subgroup proportion. And what is the label proportion? That means in terms of among this 0.08%, what are the terms that are present corresponding to depression? That is 10.1%. Okay, now we have this. Now we can do, as I told you, only apply this on false positive or false negative. But the best way is to build a robust optimization turn into a robust optimization problem. How we do that? The constraint is minimize half of the maximum of the overall false positive rates and the false positive rates over each group. So you can take mental health for mental health, or you take sexuality when we determine this fairness on the group, on the subgroup sexuality. Okay, plus half of overall false positive negative rates of the overall data set. It includes the entire data set, this corresponding subgroup. Now this is the way of minimizing the overall, and it gives the best result. And how does it gives that? So you can see the code here, and we'll share the GitHub links where it is available. It's also available in Google Colab, but we have extended it and integrated with BERT models and all different kinds of deep learning models. We show a comparative study of different models. So you see that it's half 0.5 and 0.5% of this FPR and FNR. So they're false negative. And then we apply the Lagrangian optimizer, and then we get the results. Okay, now let's go through that. What are the results we see? So remember, whenever we apply fairness or privacy to any deep learning model, we have to compromise a bit on the accuracy. So even if this model has given me 90% accuracy on an unconstrained model, I sacrifice my accuracy for building a constrained optimization problem and get an accuracy of 74.38%. So this is the accuracy which I get with by LSTM, and alternatively, when we try out CNN model, we get the 81.76%. And BERT model, we could not, since we did it on the laptop, it was not a larger scalable system. So we tried on a smaller data set, and that we could reach an up to an 88.7% accuracy. So now I will show you with Jupyter Notebook that what we have done, and we have put the references. You can go through this paper as well as the GitHub codes which I have shared, and provide your comments. So let me go through and share the Colab notebooks. So hope you can see my screen. Hope you can see my screen. So here I have put, there is the BERT model. Let me reshare again. Yes. So for you need to install for developing a BERT model and integrating it with constraint optimization. You need to install this PyTorch pre-trained BERT and BERT for TF2. So then you install this packages for doing text-based processing as well as plotting it. And then what we do is we download the BERT model first. So here you try to do some NLP, like you try to mention what are the columns, what are the actual columns, what are the target columns, which are the features you are going to process, and then do some removal of character and set up the hyperparameters. Now once you load this, I have it here. So I have it here. So I have the model. I've downloaded the BERT model here. So I'll show you the steps to download the BERT model. Otherwise, you can find the notebook. So I've downloaded it over here, and you have this logs for the BERT model. So what we do, the classification of the text first. This is still, now we have not gone to fairness. We will go to fairness, how we implement the optimizer over there. And so see here. So here we have done the groups. So we have defined the groups. We have defined the groups in terms of sexuality, in terms of gender identity, religion, race, mental, economic, and physical conditions. So these groups, what are the labels I have shown you, the proportions I have shown you. Now these steps I have commented because I have already downloaded the model. But first time when you are doing, you have to uncomment the code and download the model. And once you have the BERT model downloaded, you have to get the BERT embeddings, that how the text representation of the word vectors are there, and you can do some kind of pre-processing and the intention, like define your own intent detection data, like how you are doing defining the tokens, how you're processing your text, which is your output column, and return that. Okay, so this one is more on BERT model. You can go and see it, like how the BERT model works. So I have this text, I have printed it on the data, and what are the different comments, what are the different types of text that are coming in, and then we have build a model, return that model. And now I show you the most important part of, like, like incorporating fairness to it. This is a simple unconstrained model. So we have to first try and build an unconstrained model and see that what is your accuracy. So you should always try to see that your accuracy should be better in terms of individual groups, but if it is, it should not come out, because there is a trade-off between accuracy and the fairness terms. Now you see the toxic group, different groups, the group proportions, the label proportions, and you evaluate and now you have to define the first constraint, that is defining the rate of false positives. And what is the rate of false positives I have defined initially? This is the unconstrained model, and this is how it's working. And then when we define the first constraints is in terms of the true false false positives, like the false positives rate is defined to be 2%, and use the Lagrange area optimizer and get it running with this of the different subgroups. Then how does it work with the Lagrange proxy LO optimizer? How it works? It works in terms of 2 mini batches. So most of you who have worked on TensorFlow would know that what is the term mini batch means. So it first is the mini batch involving the entire data set, and the second mini batch will come from each of the groups. Okay, so because we have so many subgroups in terms of all the defined parameters what we have initialized. Okay, and now 2 mini batches will comprise try to optimize the problem and of the objective function, and we use the simple Adam optimizer. And when we try to optimize the data, will get the tensors and the features from each of the mini batches has to get copied to the main optimizer, and that tries to optimize the objective function. And now once this is I'm talking about where it gets copied to the feature, it has to be copied to the feature tensors, the batches tensors. And once we have done that, you get it takes a lot of time. The BERT model takes a lot of time to process, and once you have that, you can save your model and you can plot your constraint up. Since we have done a very limited data set for BERT, you don't see any difference, but I can show you the difference what you are seeing in contrast to this. So here you see the unconstrained model. The unconstrained model this is LSTM and CNN. The unconstrained model is plotted over here. Yeah, so the unconstrained model is plotted over here, 93.22. But once we go down and try to plot a constrained model with the constrained model, that accuracy decreases. That happens for each and every model, because we have done it on the entire data set. Okay, now this is only on false positives, and then you for each of the subgroups you have to test how your model is behaving. What is the false positive? What is the false negative? See, this is all constrained. This is within 2%, but the false negative rates is higher, so we cannot freeze here. So we have to look for ways to improve both of this, the false positive and false negative, and that's how we do with a robust model. So with the robust model, we have done it in BERT, we have done it with LSTM, CNN, by LSTM, and compare all. I think CNN or by LSTM, I have concentrated that on the slide, which one works better. So here we do both on the false positive and both on the false negative, that is the half of the false positive of the group as well as the entire data set. So that's how we implement that. And then if you see the robust model, is accuracy also decreases compared to 93%. We are here at 80% to 81%. So there is a trade-off that we have to understand, that we can incorporate fairness as well as privacy, but that it comes an act, and we have to achieve at an acceptable trade-off, that what my business is going to tolerate between by incorporating fairness. And then we look at this individual subgroups. What are the individual subgroups? Like here you see that in terms of sexuality, what are the false positive, false negative rates. You calculate the precision, recall of everything. Okay, so that gives overall understanding of how you train a fairness model. I know I can't go to every lines of code, or this running it takes too much time to run. So this is, I have tried to explain it, go through the notebooks, and it's also there in Google Colab. We have just extended by adding some of the features. So you can see here we have done using like diabetes, all the physical illnesses, mental illnesses I have shown you, and the performance for each and individual one is as well as on the entire groups. So how we are plotting it and how we are able to achieve a fair model. So it's there. So we can take some questions, and here you will see the BERT model. So BERT model's accuracy also drops down from over 90% to 88%. And then you see the finite groups. So finite groups has, because it's a limited data set, you can see a much less.
Yeah. Okay. That was an awesome session. Thank you so much for sharing about your perspectives. We have some questions. I will take one. And the question is on your screen. So, how would you prevent heavy computing while addressing biases? Like, majorly it is termed
So
as when you are. Go ahead.
Yeah. So first of all, if you are computing on huge data set, you have to look for distributed training using Google Cloud Platform. You cannot go on the problem which I faced when using BERT on a local system. Say it cannot handle. And heavy computing means you have to use distributed, like you have to bifurcate into number of nodes and handle it and gather the data from all the different estimators or from all the different clusters and finally achieve at that. So how do you prevent heavy computing while addressing bias? I think the only solution is distributed computing. Without that, it cannot sustain for large scale systems.
Okay, that's an awesome perspective. Okay, would you like to add something?
Charming, me? Yeah.
No,
Yeah,
I guess, yeah, Sarmisha's answer describes it very well. So,
okay. Okay. So I would like to invite Sayak. Sayak would take one more question and then invite the next speaker.
Hi, folks. So I just had one question regarding the constraint-based optimizer that you folks presented. What's your experience with using monotonicity constraint with regards to using constraint-based optimizers in the first place? Because if my understanding is correct, the optimization landscape that you just presented would only work with the systems that kind of follow the gradient-based learning paradigm. So go ahead.
Yeah, so have a look for the proxy-based optimizers. So the normal Lagrangian-based optimizers were not able to handle the gradient-based learning. So there's a research paper which I tried to put it into one of the references. So that they have come up with a proxy Lagrangian-based optimizer which handles gradient descent learning. So if you are not looking for gradient descent learning, if you are looking for other kinds of learning, then you won't have a M+1 deterministic solution. There you can go ahead with the Lagrangian optimizer without using the proxy, which is the added new addition to this TensorFlow constant optimization module.
Okay, so my question was more on the linear kind of model or rule-based models. For example, if I were to make my XGBoost classifier bias-free, so what would you prefer there? Would you prefer these kind of optimization landscape, or would you rather go with monotonicity-based constraints and stuff?
You define your own constraints. Suppose I talk about clustering or XGBoost, or decision tree classifiers, right? So how do you split the decision tree? So what are the groups which you have at the first split of the node? What are the groups you are forming? Or clustering, what are the groups you are forming in the clustering? So here you define that when you are forming 80% of your population from the majority, you should incorporate 10% of the population from the minority. So this is on definition of the constraints that you define, that you can develop your own algorithm. So there have been a lot of research and people have come out with clustering based fairness, like a decision tree based fairness, and at each algorithm it is dependent upon you how you define it and then how you put it into your model. So it depends upon you can define it, and so you also
go ahead.
And you also have to like calculate what is the trade-off you're making between your accuracy and the fairness constraint that you have applied to your algorithm.
Cool, that really makes sense. So the definition of constraints still lie with us. I mean, the folks that would be handling the constraint definition, still that needs to be corrected in the first place. So there cannot be an automatic implicit regularization that would come into place. We still need to get into the scene and
exactly,
get
exactly. And then and research is continuing on defining different kinds of constraints for different models.
that makes sense. That totally makes sense. Thanks, Sharmi. Thanks, Sharmishta, for your valuable insights, and I truly appreciate that. So,
Yeah.
thank you. Okay, that brings us to our next session, and I'm back again. So our next speaker is Kuldeep. Kuldeep is also a fellow TFUG organizer. He is a TFUG organizer for Delhi. Kuldeep brings with him 12 years of experience in machine learning, data science, and DevOps. He is a seasoned AI practitioner. And without any further ado, in the interest of time, I'll straight hand it off to Kuldeep. Kuldeep, why don't you take it away?
All right. Thanks, Zach. Hi, everyone. Good morning, good evening, or good afternoon in whatever time zone you are. Yeah, so I think we are running a bit out of time, and so let's directly jump to the session. And I have shared my screen, so let me know, Zach, if you're not able to see this screen. Okay. Yeah, so the today's topic which we are going to talk, it is like for TensorFlow for production, and we are going to talk about the TensorFlow Extended. TensorFlow Extended is like pipeline workflows for running your machine learning workload in production. And we'll talk about why it is needed at this point of time more rather than what it was in the earlier. Yeah, so a bit about me, which Sayak already explained. Other than this, like on the personal front, like I'm married to a very wingly wife and father of 2 daughters. So in case you are wondering like how I'm spending my time after office hours and after the community, it is like this. These kids keeps me busy. And I'm reachable at the LinkedIn and the email address, which is mentioned. So these are the 2 preferred way of communicating. And I know we are just having 30 more minutes to talk about this topic, and it really requires longer session. But yeah, even after this session, we'll be happy to discuss with you all anything which is more related to the TFX or overall TensorFlow as well. Yeah, so I think the agenda is quite packed, and I will try to summarize it. The idea is to give kind of the overview about all the components, all the how the data flow will happen, what are the relationship between the libraries, component, and how a typical ML system looks like, which will be followed by a demo, and then we will take the Q&A part. All right, so. The first thing I think even before starting something and all, we need to ask a question to ourselves, right? Why itself we are doing it? And there are a couple of things which it comes to my mind, and this happened to me as well. It is not something that I haven't gone through it. I used to thought that once I have written a code and I have run it specifically into the notebook, this is how the end-to-end system looks like. But the AI or the machine learning system doesn't just produce the value if you just run them into the notebook. Second thing is the data science workflow, right? The steps which you take it from starting, from the data to the end result to your model to the published part. It is not easier, to reuse. There are many things, many moving components which comes into the picture, which is not as simple as like just putting it into. The third main thing, it is like, okay, some few things runs on my local machine, and they don't exactly run on the production machine or into your enterprise setup. Is it something like you can easily do this migration? You can easily scale it from development to the deployment, or something which it comes more related to the stats, like which I have mentioned here in it. And I mean I'm not going much into detail whether it's 60% or 70% or 62%. The main idea, it is like most of the data science projects gets fail if it is not executed with with uh, the, of course there are many things which contribute to success and failure, but one of the main thing which we have seen is like putting them into the production. Your model works fine, your everything works fine, but when you try to integrate with your IT ecosystem, when you try to really leverage that into your mobile app, into your laptop, into your you know attest IT attest IT integration, it doesn't work it out. So the idea is like how we can solve this problem, and TensorFlow does it. So how the TensorFlow does it? So I'm just giving you the overview why we are calling TensorFlow as a platform. So if we just divide into four more buckets. One library which most of us have started using it specifically for the neural network and the deep learning is the TensorFlow core, which is like wrapper with Keras. The second main bucket or second main the stream is TensorFlow.js, which we already had session on in the last two the first day and the second day. The third main bucket is the TensorFlow Lite, which is mainly for the mobile, which is mainly for the IoT type of a device, which are not having compute heavy or which doesn't have all those facilities. And in the last, TensorFlow as an organization or as an open source project has dedicated a stream to it for the pipelining and the framework, which is called the TensorFlow Extended, and in short, it is TFX. So what exactly is TFX? So TFX is, if you ask me a definition, it is a platform for deploying production machine learning pipelines. So and when do you really need it? When you are really looking forward for your model from research to production, use TFX to create and manage your production pipeline. And as usual, the pipeline is a sequence of components. So it is not something I'll just give you one package which will do the entire stuff, because the machine learning is again very it could be very specific to an organization, but it is more related to the steps which are there. And the fourth main the advantage or something which it comes is like the pipeline components are built using the TFX libraries, which can be used individually, which means you can modify your workflow, or you can modify something based on your needs. And the main part which it is it includes modeling, training, serving, and managing deployment to online, even till mobile or the JavaScript targets. That's how the TensorFlow Extended is being used. So coming it from the library, so if we divide it into four main bucket, one is like the TensorFlow data validation, TensorFlow transform, model analysis, and serving. So if you guys see it, so these are series of steps or the event which you normally take it. First come is the data validation. So this is something like any project or any machine learning project which you do. What you exactly first do is you analyze and you validate your data set. So this is the library which helps you with it. Second thing is the transform. So I mean, whenever we take a data set, it is not kind of we can just take the raw data and we can do it. There are many type of thing which happens, like in case of NLP, we take the different format, we tokenize, we stem it, we form vocabulary, and we perform the numerical operation, normalization, etc. This is something which comes under the TensorFlow transform. The third part is something like, okay, your data is good and your model is ready. What you exactly can do with the model? So this is called the model analysis, or in short TFMA. It is something to visualize or to evaluate the matrices for your model, so that you can come to know whether the specific quality has been maintained, or whether the model is performing within the specified limits. And if not, then this doesn't go to the next stage, and it fails, at the model analysis gate, and it doesn't go to the production. The last part, your model is ready, everything is ready. Now you are looking it for the serving part. So this is something, I mean, the serving, it could be, you can use the multiple platform it is, which are available out of the box from the cloud provider, or you can use, even the TensorFlow serving, which is again, the open source part of the TensorFlow toolkit. Now coming to the components, and it might be kind of a confusing sometime, like the library and components. So we will come into that. But yeah, so the pipeline is kind of, which includes, the component. And so these are like, 9 to 10 main components, which is specifically, I would say, most of the time you need it, unless you are solving a very specific problem, which is not kind of, generic enough. These components are to handle a data science generic project. So example gen, it is like what you do with the data, right? So you just take the data, you then split it out, and then you give it you give that the input data set. Then for calculating the statistics for the data set, because you need its mean, median, average, or the other stats which you wanted it to do, this is something which it does. Example validator. So this is something like for the anomaly and the missing value, etc. This is something which we use. Transform is as the name indicates, and I mean, these are kind of, the name have been kept so that you can just take a look and you can understand what it is. So transform is mainly for the feature engineering part. Trainer is like trains the model. Tuner is meant for the hyperparameter tuning, and evaluator. This is something kind of, the deep analysis of model, whether it is good enough to be production. Infra validator, it is like more checks from the infrastructure perspective, right? So it could be that your model is fine, but it is not servable at the infrastructure level, whether it is due to more increase into your response time, or it is more, not like the loading itself taking longer time. So this is to ensure those checks. And pusher, it is like deploying the model on the serving infrastructure, whether you are using like your on-prem or whether you are using some sort of the cloud vendor. So this is how a typical the data flow diagram looks like, right? So you put up the data, which is like in this, then it is being sent to example gen, statistic gen, which does like example validator, schema gen, transform, then it goes to tuner, trainer, in the end, the evaluator, then it again the infra validator comes, and then from the pusher it goes to whether you use hub or you use JavaScript Lite or the TensorFlow serving. So this is kind of how the data flow happens between the different component of the TFX. Yeah, I think this is kind of the important slide from the relationship perspective. As I mentioned you before, so like these components are something, the component which make it, but these component, from the user perspective and even from the work perspective has been mapped with this. So like the example gen is more for the data ingestion. So these are the normal process which we does. It's like whenever we start with any machine learning project, we do the data ingestion, then we do a data validation, then we do a transform, then we do a keras modeling, then we do a model analysis, then we validate it, and then in the end we deploy the model into the production. So if we just take it from the back, so the TensorFlow serving is like the model server part, validation is more related to the pusher, and evaluator is more for the model analysis. For the tuner and the trainer part is something related to the estimator, and transform is like exactly one map. You do the data transformation, and the data validation. There are different, the three main validation which is being used: statistics, schema, and the example validator. So this is how it is exactly mapped into it. You can fine tune. I mean, it is not mandatory that you are just using them as is. You can modify it even if some component you are not making sense. Like let's say the data validation is something which you have ensured that your source system you don't want to include it. This is something a facility available here. And a typical, the ML system. And I think this is kind of, giving you the how when you do have the data and when you do your system architecture, or you define, how your data workflow will happen. This is where it is being used. So you start with a data source, you do a data extraction, then you take the raw data. So this is kind of till the input system. Then the TensorFlow data validation, it validate your data against your schema. If it find some of the anomalies, it asks you, or it even it asks you to fix the data and update schema, or it is like if your schema is outdated, you just fix up your schema. If the data validation is okay, then it goes to the next stage, which is TensorFlow transform. So it's pre-process your data and engineer feature, and then add pre-transform artifacts. And then again, this is the test and training split. Then it goes to the model analysis. You evaluate your matrices. Is my model validation okay? If okay, everything okay, then it goes to the TensorFlow serving. So these are kind of, even from the estimator, you are evaluating, the saved model, and then you are, your saved model is being served through TensorFlow serving. So if you just see it, it is kind of the multiple gate processes, right? So your system can be into a problem into these layers. So the layers, the problem could happen at the raw data level, the issue could happen at the model level, or even at the at the serving level. So this is how this TFX system has been designed to allow you to use these libraries and component, and to make your workflow that you can easily reproduce, you can easily verify it, and all. Once you define it, it is like just again running with the standards. And if it find any issue with it, then this is something you can catch it up at that layer itself. So this is really helpful when you design your system for your production workflow. Coming into the demo, since we are we were just having 30 minutes, I have just kept 5 minutes for this model, and we will be sharing this the slide which contains the link for the GitHub. I'll just demo you as well. And I have created it as a public repo, which will be shared with all the attendees. And for the future discussion, if you wanted to do it at the GitHub level, either through pull request or issues, etc., we can do it. And for the demo is something which I'll be using one machine which I have set it up, and how the workflow looks like. So let me open up the demo link basically, and I'll switch my screen share. So let me share my screen. Okay. Yeah. So this is kind of the README file which is here. So this is kind of the main repo for the TensorFlow TFX which is being used for running this test. It is like with the Airflow. Airflow is the pipelining orchestration, right? So you can build the pipeline, but how you are going to schedule and run it. So this is something which you can use, the Airflow. You can definitely use even the Kubeflow, etc. I have just used in this example the Airflow way, but there are tutorials and the session available for it. As usual, if we come to the prerequisites, it is either Linux or Mac OS preferred, where we would be the virtual environment. You need to have access to Git, and Python should be 3.5 plus. In this tutorial, how exactly we are learning how to create an ML pipeline using these TFX, and these are kind of the useful when you are deploying it into production, when your data set is large and your serving consistency is important. When I say to the serving consistency, which means like, let's say if you have deployed a model for the classification, right? So your classification consistency should be there, which means like one consistency, it is like it should take the same amount of time for the different the request, etc. It should provide you the same type of format, same type of output, and all. And these pipelines are appropriate, right, when you do the version management, which is basically if you are checking in your code into the GitHub. And even this is somewhere like Google use these TFUG pipelines for the production machine learning process. And this demo itself as well, which contains these 5 main components, right? Ingesting the data, understanding and cleaning your data, then you do, followed by feature engineering, then you train, then you analyze your model performance, then this is like fine tuning of your model. And once you are ready for your production, you can deploy it into the TensorFlow serving. We are using in this the taxi trip dataset, which has been released by City of Chicago. The model goal is very simple. It is binary classification. Will the customer tip more or less than the 20%, right? So, and Airflow is being used as the pipeline orchestrator. So this is kind of the overall goal for this session. And coming into the setup, etc. I mean, I could have been used my local machine, but there was some configuration issue which it comes with the Airflow. So I have used GCP platform. I have spinned up a machine here, and with the TFX, it is like high-end capacity machine. I would say it is like 8 CPU and 16 gig RAM, which works fine like for this the standard data set. But if you need more pipelining, etc., which is something which you need to do it. Yeah, so once you go through this setup, etc., the instructions are self-explanatory, and you will set up your pipelining through Airflow. And with the Airflow, if we have scheduled, I just ran it before the session, just to ensure, because sometimes the things gets broken specifically during the demo. So I ensured it is running and fine. Yeah, so this is kind of the end-to-end run for it. So Airflow is something which you can just use it to visualize, right? So it gives you the CSV example gen, then what is it is having dependency, what is like pre-input and the post output, etc. And if everything it is like showing green, then which means everything has worked it out. If not, the things will get broken here. Then the pipelining will stop here. So if we see it from the standard data set, etc., how exactly we can see it. So the person who has written these code, it is being written into Python. So let's just take the example with the transform mechanism. So this is sort of the code which is being used here, and this is kind of the component pipeline information, etc. So this is typical into the Python project, how it is being handled into the Airflow. So coming into the DAGs, etc. If we just see under the DAG, etc., this will be the code which will be available, and these will be kind of changing it for everything. If as usually you can use some sort of render template as well, like if the configuration, etc., which is being used, then you can have a look on the logs itself. This is specifically helpful for you when you run it and some issue comes. This is how from the logs itself I came to know about the issues on my local machine, and it fairly gives you all sort of a logging, etc., which which helps you. So it's like, okay, now I'm starting with the attempt 1 on one, where the attempt has started. Now it's running on this host, then running driver for transform, because we know then the metadata stored with DB connection, now running publisher for transform, and everything. In the end, if the task is completed, it will mark it as success. If it will be kind of fail, it will give you, the written code other than the zero, which is kind of a standard it is. You can check it with the graph view. You can even do a tree view as well if that makes you kind of more comfortable. So which means like this is the pusher is having dependence on the evaluator and on the resolver. The CSV example gen evaluator is like dependent on CSV example gen. Then this is kind of in the different branches it comes. So this is how kind of the different pipelining which you can set up using direct using the TFX on any sort of a scheduler. And with the queue flow, also the examples are there, but we will not be able to take into this. Probably will schedule other dedicated sessions for it. Yeah, and the DAG details. So this is something kind of which also you are able to see here as well. What all are the task ID which has been done. If you wanted to have a look on the code, etc. This is how the entire code look like. So we, as usual, the program starts with importing of these library, which we are doing it for like TensorFlow, and we are using these components specific. So this is kind of the granularity which we can use it, like CSV example gen. So which means if I don't want to use one component out of it, I could be just skipping it that part. Then we define it as a pipelining name, and then we start with it. So this is kind of the standard. I mean, we'll just start with like the trainer, which it is the trainer argument. What is the model, which is kind of the latest model we are being used. Then in the end, the TFMA is being used. What is the class name, like the binary accuracy, right? We wanted to see whether it's more than 20% or not. Then on the model analyzer, these are something which is being used. Then in the end, once the model pass the validation, it pushes to a file. Basically, as of now, we are pushing the model into a file which we can use. And then there are related to the other components. So these are like the pipeline name, what are the component which is being used, and all. And the DAG is something directed a cyclic graph, which is kind of how all those pipeline, etc., which is being used. So you see, how clean your code is, right? If you just wanted it to write through notebooks, or you wanted it to write it, any other system and all, with TFX, it becomes easier. It becomes very much cleaner, standardized and all. And this is kind of the code which can be checked into GitHub, and you can version it. You can change some of the component, etc. You can share with your team member, and you can always scale it up. Yeah. So if this code wouldn't have been there, we would have written specific custom function here, and those specific function would have been created and all, which would not be have standardized output, which might have missed some of the stuff. And the third thing, it is like every developer uses different sort of the standard for their own function, which creates a problem. So by using with these the standardized version, which comes it from the TFX itself and from the core TensorFlow, it is very much easier to end-to-end map your machine learning pipeline for the production system, and you can scale it and all. And at any point of the time, if there are some sort of a changes, this is exactly you can just change it here, and exactly everything will follow for the same change. You will be able to use make the different changes, etc. So it is like one source of truth it becomes for you. And in the end, if I just see it, and if you just wanted it to visualize, maybe like if at the later on stages like the Gantt chart, etc., is something also which you can use, which helps you in identifying, right? So how the CSV example then took 0.491 second, right? And how the model resolver took the other, because I haven't clicked on it. Basically, this is how you can find it out, and if there is any problem in any step, if it is taking more time or if it is kind of creating some problem, then this is very helpful for you. Oh, yeah, so pretty much from the demo it is, and as I said, this is available in public Git, and I'll be sharing these slides as well, which you can see it, and we can further take the question or something related to it. Coming to the resources and the community support. So this is like the TensorFlow TFX is the main site which you can just go and find more information related to it. This is pretty much into very active development. I see, some of the sessions has happened recently. The changes are coming very fast, and also it is kind of one of the core focus from the TensorFlow. You can always follow the blog. You can subscribe to the newsletter. You can use even the discussion form, and there is even a form available if you have done some good work with the TFX and wanted it to share. You can share your TFX case study here on this. There is a the YouTube channel where the videos related to the TensorFlow comes, but there is a specific playlist for the TFX as well. As usual, you can reach out to the Twitter and to the other community and the TensorFlow groups. So as I said, I'm associated with the TFUG Delhi, so which is basically one of the TensorFlow group available in India. But if you go to the meetup.com and search for the TensorFlow, even if you are not into India or you are into some other location and all, you can always subscribe to your local channel and to the other channel, etc., so that you can come to know about the further events, etc., which are coming. And as usual, it is same thing with the other component, etc. It is kind of the community-driven thing. So in case you are seeing some of the issues or etc., you wanted to get the developer to focus, feel free to raise those either through issues or through pull requests in case you had done some sort of a good contribution on these platforms. Yeah, I mean that's it from my side. I'll open it up for the Q&A.
Hey Kuldeep, thanks for the amazing session. So regarding the Q&A part, so as Robert already introduced TFX in some flavor, so probably most of the questions that our audience might have were already answered by Robert. But yeah, one of the most asked question regarding your session was whether or not you will be sharing your slides. So if you have got any links to share with them, now might be a good time so that we can pop it off on the screen so that they can get access to your materials.
Yeah, so it is part on the drive. I'll just share the link in the chat just after this talk.
Yeah, sure. I think that works. Thank you. Thank you, Kuldeep.
All right.
Thank you for joining here today, and we'll hope to see you soon.
Sure. Thank you very much. Have a nice day, or have a good night, everyone. Bye.
And I also wanted to let you folks know about the Manning discount that Manning has generously provided us with. So Manning is currently supporting us with a generous 35% discount across all of its products. And here's the coupon code for that. So if you are interested in picking up a Manning book, or maybe a Manning Life project, or maybe a Manning Life course, now might be a very good time to consider it. So with that, I'm gonna hand it off to Ali again.
Hello, everyone. I hope you are doing good. And please be active in chat. What's happened? I'm not able to see you guys in chat, right? I also did a fit model, and I guess some people waked up, but I'm going to write fit again. Okay. Okay. So let me introduce you to our very next speaker, Dharmesh Vaya. And I had a pleasure to work with Dharmesh on many occasions. And Dharmesh is a GD in cloud and payment, and he talks around containers, multi-cloud, serverless. He is an active member and organizer at GDG Cloud Mumbai, and he is a director of technology at Aragya. So I welcome Dharmesh. Dharmesh, the stage is all yours. You can share your screen and get started.
Hey, hi Ali. Thanks for the invite. You folks have been doing some amazing stuff at TFUG India, and it's really a pleasure to be a part of this. So not wasting too much time, I'll kind of kickstart the session right away. Uh, so what we are going to talk in this session, okay, I'll keep it as simple as possible. Disclaimer, I'm not an ML guy, okay, so you can ask any of your training model questions to the ML folks or the ML GDs. I'll be able to answer a lot of your cloud and infrastructure related queries. So I'm just safeguarding myself from all the ML kind of questions. With that, let us get started. Ali gave an introduction for me, but yeah, just to kind of tell you in brief, what are we going to cover? A quick, short, four-step agenda. What exactly is the purpose of having these serving for ML models? What is the architecture behind that? How it works? And then how do we get started? All right. Yeah, and then like how do we get started with it, basically with Docker containers and so on. And lastly, it would be more of what are the next steps towards these kind of models, or these kind of infrastructures, and extending it to the next level, maybe into a serverless model as well. That's what we'll kind of cover in short. As Ali introduced, thanks again. I'm a GDE for cloud and payments, and the director of technology at Agraya. Basically, we are a GCP partner. Plus, we do a lot of voice technologies related to cloud, plus Google Assistant, Alexa, and so on. So we are into that kind of a domain. With that, let us get started. And yeah, of course, Yoda, thank you again to be a part of my slide. To deploy, deliver, you must, I mean, that's what like Yoda says. And so to make your model available to anyone, okay, they have to be kind of deployed at some place or the other. And that is where this talk or this kind of concept comes into play, wherein how do you kind of actually deploy, or how do you actually deliver these models, or these kind of TensorFlow models that you are kind of developing. So let us kind of first understand what exactly is the purpose and the overview of this whole talk, and then we kind of get started with it. So, before even I dive into the purpose, let us try to understand this whole realm, or this whole landscape, okay, around machine learning, DevOps, and including data engineering. So, if you talk of like you folks like tensors, I would say y'all are more inclined towards the machine learning side of things. However, when you develop these models, okay, it is the task of cloud engineers or cloud architects like us to kind of get it deployed along with your application. Now, I cannot just have a model residing somewhere but it is not kind of available for the end user. That cannot happen, right? So you'll develop the best of the class models, but then how do you kind of deliver it to your audience, to your end users? That is where this new sort of a stream is kind of coming up and picking pace, which you can classify it as ML ops. Now, what exactly is ML ops? So it is more of a amalgamation of ML, DevOps, and a bit of data engineering as well, since like ML relies like kind of heavily on data. So that's why like you need to kind of manage all the infrastructure related to the data, or even like kind of manage the entire scalability factors for these applications that you are kind of deploying. So that is why it's not just DevOps, it's not just ML, it's an amalgamation which kind of boils down to more of ML ops. Now the roles are pretty much similar to what DevOps do. However, they might have a bit of an edge towards the ML side of things, because they need to understand those use cases, understand what are those data layers that they are being worked for in terms of scalability or in terms of training or inference data and so on. So that is why it is a bit towards the ML side of things. However, it talks a lot around the DevOps side of things in terms of the infrastructure. Okay, again, like coming to our like problem around like what exactly is the purpose, okay, of the talk, or kind of how, what we are going to do with TensorFlow serving. So I believe like the left hand side of the sketch that you can see over here, there is TensorFlow. In between there is data, okay, which obviously is kind of the basis for kind of making your models and developing your models. And of course it is your brains, your developers, your data scientists, your analysts, who are kind of playing with TensorFlow to kind of extract the meaningful insights out of the data and extract or create a model out of it. Now, as I said earlier, the model is ready, model is created, okay, but then you have, let's say, a very beautiful web application which you want to kind of integrate this model into. How are you going to do that? That is where this block, this question mark comes into picture. So then what exactly is that block, and how are we going to uh, kind of deploy our models onto it? So that's where we see in depth around this talk, that you have your models created, okay, now how do you integrate that into an application? Now you might think that containers are the best way. Yes, they are, okay, but then how do you kind of create your models, okay, on like, I mean, containerize your models? So just for more of the ML folks out here, what exactly is containers? You can call that as the smallest unit of your code that can actually run along with all the dependencies. So let's say you have a small package, okay, or a model, okay, which let's say it depends on 3 libraries or n number of libraries, okay, those are all the dependencies, okay, and you want that to be available to some external facing application in the form of a REST API, or as a gRPC call. So that is where like containers will help you, okay, in defining that smallest unit of software, okay, and it is being made available. Now, then what exactly is Docker for just beginning? I mean, just for beginners. Okay, so Docker is basically a tool that is used to create, manage, or kind of deploy your containers. So that actually helps you run the containers and manage these containers. So then now what is Kubernetes? So again, like I hope this is not very confusing for the ML folks, but yeah, it's just a very basic terminology which I'm trying to cover and set the context. So Kubernetes is nothing but it helps you manage, or rather automate, they call it like orchestrate n number of containers. So you just don't have one container running at any given point of time. The whole purpose of containerization is to get the level of scalability that you need, and that is where like you will have like n number of containers running in tandem, and they will do the job for you. So that is where like Kubernetes comes into picture, and so it is basically helping you manage n number of containers. Now, not going a bit of deep dive again, but then it's like Kubernetes again. Within the containers there will be something called as pods, and those pods will have services and so on. Not diving too much into that, just keeping it at a high level abstraction of like what exactly would be containers, Docker, and Kubernetes as a starter. So then, like, what exactly uh, does the TensorFlow serving do for us? Then, in this case, so the whole idea of this. Let me go back to this slide. It's like when you have your model ready. Okay, you want it getting deployed as like as a container to the any application that you want to integrate that with. Okay, so it's better that your entire model comes along with all the dependencies. It's kind of readily available with all the packages and so on. So then when you talk of like Kubernetes, or you talk of containers as such, okay, it does the job for you. But then how does the TensorFlow part of it work? So that is where this thing comes into play, which is like TensorFlow serving. What it does is gives you a capability, or gives your architecture or capability, such that it also lets you like kind of manage your models, okay, or rather kind of have a sort of a internal source control for your models. Plus it also allows you to serve your models, okay, via API calls or grpc calls, and that is where it can be like kind of integrated into the container world. So let's go into the TensorFlow serving part of things. Okay, so it's more of you can say it's like a platform, or a way in which just call it as a wrapper around your containers, or that is actually your container, which will help you build like machine learning models for scale. And you can have your like custom algorithms or your custom models deployed into it. Uh, as at the same time, it gives you the flexibility that you do not have to change your architecture or your application APIs just to kind of inculcate machine learning into it. So the best part is like what happens is like ideally in like an enterprise world, people would develop a huge enterprise application, and then they think that, oh wow, I have so much of data, let's kind of build some ML models on top of this. But then to integrate that ML model, they don't want to kind of change their whole application landscape. Their applications might already be containerized. They're running on n number of Kubernetes clusters and so on, and that is where like TensorFlow serving it helps you kind of design your. I mean, it's more of a plug and play for your Kubernetes landscape or your containerized landscapes of architectures. So what it does is basically it gives you like ready integration with your TensorFlow models, but then it's like allowed to like kind of extend even beyond just TensorFlow models. But we'll concentrate more around the TensorFlow models that you kind of have been working with. So then like let's again connect the dots. So that piece of question mark that we had in the earlier slide, uh, assume that that is the TensorFlow serving, which will kind of help us connect with everything. But then if you talk of like how exactly it is going to scale up and so on, okay, uh, then you can kind of like use Docker and Kubernetes for like kind of achieving that level of scalability in your application. So that's more about the basis of how this whole landscape works. But then like what exactly goes inside your TensorFlow servings, and then how exactly it kind of integrates with your containers, let us see in this part of the session. So okay, this is like a very standard kind of architecture, or this is more of the core of the TensorFlow serving. Now, I won't get too much into the depths of this, like considering the brevity of time and resources. But yeah, what I would kind of say is that it contains like the four uh, like major modules of TensorFlow serving, which is like the servable. Okay, so just like kind of if you all are like DevOps guys, if you want to like kind of relate this to like pods or containers, this kind of relate to that. Servable is that particular unit, okay, which kind of helps you like kind of interact with the model. Okay, so that is where basically the model is being interacted from, and all the computations or all the lookups, inference, everything is happening on the servable. The next part is basically the loaders. Okay, so what exactly loaders are doing is basically like these are basically helping you to kind of load and unload the servable. So servables are kind of giving you an access to your models, but then your models can keep on updating, and that is where like loaders will come into picture, which is like it's more like API driven internally, and it kind of helps you load unload models. Then there is something like sources and managers. I'll rather like sources is basically like the you can call that the module or like the file system which kind of integrates with your data and your models, and it kind of gives you a chain to kind of interact with it. But then like the main part is the managers out here, which kind of help you to kind of not just manage the entire life cycle of the TensorFlow servable, okay, but not just load and unload, but it also helps you serve the servables. So the manager is actually responsible for like kind of listening to any changes, or track all the version changes and so on. Okay, and it actually helps you like kind of serve it as a servable from the model perspective. So that's what like kind of I have written on the slide, is that your sources, they create loaders for servable versions, and then loaders are basically kind of they look up to the managers in terms of which version should I be kind of loading, which version should I be unloading, and then serves them to the client upon request. So that's more about like the core architecture of what goes inside a TensorFlow serving. But then this is not something for y'all to worry about. This entire thing now is like kind of available as you can say like more of an as a Docker image. You just have to kind of pull this, create an image on top of this, and then add your like integrate your models on top of this, and then your job is done. So that is where TensorFlow serving as such kind of helps us share the models or serve the models in the fastest possible time. So with that, like kind of let's proceed on the next part of this, like how do you get actually started with Docker or Kubernetes for that matter. So I would say like whenever you are like kind of considering Kubernetes, just ensure that you have at least tried your applications like as a containerized application, as a standalone Docker container. The reason is like, of course, Kubernetes is going to do that on a wider scale, but assume that if you are doing it in Kubernetes as a unit test, run it on Docker for once. Just don't kind of kind of go full fledged with your containers directly on Kubernetes. It's good to kind of understand like how your containers are working, how it's kind of behaving, and so on, before you kind of end up in a full blown scaled up model. So what are the steps involved? I'll just quickly like kind of explain that. What you need to do is like any GCP instance, just have a Docker installed on that. Okay, set up your Docker daemon running on that. Then run your TensorFlow serving. Okay, so to run the TensorFlow serving, it's a very simple like a doc command that you need to kind of fire. Okay, I'll be sharing a whole like kind of a tutorial, not a tutorial, but it's more like the entire code or with these steps is available on GitHub as well as on the the TensorFlow website itself. So you can kind of refer that. The same steps remain. And I'm more of helping you kind of understand the whole idea, the flow behind this. Then like after you launch your TensorFlow serving, okay, you have to like copy your model data into these containers. So it's again a very simple like copy process. This actually does the job for you. So that's it. You have your Docker daemon running, you kind of run it as a TensorFlow serving container, and you copy your model data onto the container. That's it. Like your TensorFlow serving plus your model data, your container is ready. So if you see at this step, basically sorry, if you see at this step, the fourth one, your container is ready. You just need to commit your container and push it to the container registry. That kind of helps you like kind of push it onto like the Kubernetes clusters in the subsequent steps. uh, the last step is more of a test step. You kind of start your container and check it on the gRPC port 8500. That's more of like the standard port where your TensorFlow servings would be kind of working. However, you can like kind of change that as needed. So this was like more of a workflow which you can kind of orchestrate or rather like kind of have it ready. So how does this like kind of appear in the form of a code? I would have a demo, but then like kind of I kind of cut short that just to kind of explain the code. It would be the same stuff. With Docker, you're kind of pulling the image for TensorFlow serving, okay, and you're kind of like pushing like this. You're just defining your test data out here, like wherever you have kind of stored that. Then you start your TensorFlow container, okay, and enable the REST API port for that, which is on 8500 or 8501, okay, and that's basically doing the job for you in terms of getting your container started, okay. So your container is ready, your container is kind of created, and this is more of your Docker file, which is going to create the image for you. And like again, I've just added this thing for more of a test, okay, which is as good as this step, okay. And it's like kind of it's just firing a curl command on the localhost on this port to kind of fetch some output from your model, and with that like kind of it should expect this output to be provided, like the model is working fine and it has been containerized. So this is like what exactly TensorFlow serving would expect before to be ready, before it kind of you can push this on to Kubernetes or Docker. Now, okay, so do I need to be like a Kubernetes expert? So not really. I would not say too much of a Kubernetes expert. You just need to be aware that you should be able to create a container, create a cluster. That's it. If you have managed to kind of follow the previous slide in terms of just creating the Docker container or like a containerized version of your model, that is sufficient to kind of run that on Kubernetes. I mean, of course, like Kubernetes has a lot of advanced stuff in terms of like you can say in terms of like your microservices applications or the way in which it deals with observability or reporting with Prometheus and so on, okay. It is kind of fairly easy, okay, to kind of understand Kubernetes. It's more of configurations that you need to understand. So you don't really need to be a heavy expert, just the basic of Linux and certain syntaxes that you should be like kind of understanding. Okay, so now the core of our kind of talk, which is like kind of serving it on Kubernetes. Okay, so the first thing that you need to do is, of course, have your GCP application or your GCP project ready with a Kubernetes cluster. Creating a cluster is again like a one-step, two-step process. You just kind of auth into your GCP cluster, GCP project, then create a cluster on top of that. Your cluster is ready. You'll see that using like the kubectl commands that your clusters will be ready with any number of pods that you have kind of defined. The next part would be like mainly to kind of where do you kind of what do you run on your cluster. So you have created a cluster. I mean, those are like machines which are running like VMs. But then what exactly do you run on top of that? So that is where the Docker container that we created. So if you see like this piece, if I'm able to like kind of highlight. Okay, so if you see this part, okay, your container was already ready in the previous steps. You just have to push this Docker image into the GCR registry, like I mean the container registry. And on Kubernetes, you just need to kind of push this, or rather on Kubernetes, you just need to pull this image, okay, from GCR, and that's it. Your like kind of 50% of your task is done to kind of run it on Kubernetes. The next part is mainly like kind of defining how much of scalability you need, how do you want it to be available, whether you need a load balancer or not, and which can be fairly defined in the form of a YAML file. With that, like with this step, your Kubernetes cluster is kind of ready and servable, okay, for external traffic using a load balancer. Now, if you might be thinking like, okay, but like how exactly you do this step, okay, so that's what we see in the next slide. So this is nothing but a YAML file. Again, yet another markup language, you can say, which you need to understand to kind of understand Kubernetes, or rather configure Kubernetes. Okay, it's fairly a simple, like it's more of a like a key value hash map kind of a thing. Then in terms of like kind of defining what syntax or what kind of configurations you need, here like I have defined like I need 3 replicas. This is like going to be this is the current application version. Which app I'm going to run, it's like the name of the application you can give, and the important part is like which container you want to run and on which port. So if like fairly simple like syntax, of course, as compared to ML, like these are like fairly simpler syntaxes that you need to kind of understand, and it's mainly configurations. And then you just kind of specify which port you need to run, whether you want to run it as a with a load balancer or not, and that is where like you kind of specify everything over here. So with this YAML file, at least your model that was kind of available only on your Jupyter notebook or running locally on your systems, at least it will be now servable. Okay, if it all had to be like kind of integrated into a standard application, this model, I mean this deployment of Kubernetes will let the uh, the model available as a service, like just I mean in this case it's like the standard ResNet service, which has been like kind of fairly used across all the tutorials in TF. Okay, and it will be available as an API call or a gRPC call, which you can do it uh, from your applications, and you can get the desired output again in the form of a JSON. So then that's like kind of giving you a overall idea. So what we did, like going back to our like slide, like over here. Okay, so you had it deployed on a TensorFlow serving, but then it does not solve the the scalability purposes, or like if you want to like kind of you can again like I mean you can have your own write your own API layers, or run even like a small Flask application or a Flask API server or a Flask REST application, but then it really won't give you that level of scalability, and in terms of like if you want to expand it further, it might not really be the best thing to do. So that is where like you kind of have your TensorFlow serving, push it onto like deploy it as a Kubernetes cluster, and then like get your job done. So this question mark is now like kind of it makes sense that now this okay is sorry I think yeah, this is now a TensorFlow serving with Kubernetes, and that basically concludes most of the part of our talk today. Okay, so what exactly is like the next steps in terms of deploying a TensorFlow models? Is it just the TensorFlow serving, or you can really do it in a serverless manner? So just going back a bit to the MLOps slide, wherein like see like basically CI/CD is more of a process that you can like kind of inculcate in any of the software development practices. Likewise, ML is also code. Okay, please don't treat it differently. Although like that's more of a like it's a different domain altogether. But then it's also a code that needs to run somewhere. The deployments might not be that frequent as like any other application, but then if you kind of really understand it in depth, it requires much more frequent deployment, especially when you are developing your models and like kind of training it. It needs to be deployed a lot more frequently, and that should happen in a seamless manner. So that's why like CI/CD is important for ML, and that's where like this branch of ML ops like comes into play. So the difference over here is like ML is not just code. It will be code with data, and which will require a lot of substantial amount of infrastructure management, and hence like we term it as special DevOps or like ML ops, and that is where the branch is kind of streaming into. Although like I mean, if you talk in terms of the industry, it is still like somewhere between DevOps and between it's just mainly between like an advanced version or an extended version of ML. Sorry, DevOps. Sorry for that. But yeah, it's the job descriptions are still not well defined for that. People might expect you to know a bit of ML, or they might be expecting you to know a lot of in terms of like the DevOps side of things or the infrastructure side of things. So it really depends on what kind of use case or what kind of business problem that you're trying to solve, and how your models are going to be used in production lifecycle. The role is going to be shaped up in that manner. But then like coming more towards like the future of how these models are going to be deployed, perhaps like one way is of course the containerized manner. And like I believe like if anything can be containerized, it can be also deployed in a serverless manner, maybe like as Cloud Run, maybe as like into like AWS Lambda or so on, or any other tools or solution in the serverless realm that you can think of. So yes, like any model that you develop, don't just think it from like it is going to consume heavy resources or so on. If it's like kind of able to like kind of make it more in terms of like as a container, okay, you can very well deploy that as a serverless process as well. And similarly, like there is Kubeflow also that you can use, and you can kind of use it for like orchestration of your ML models on like Kubernetes. Even that kind of helps a lot to kind of manage your ML models and deploy them in this manner. So TensorFlow serving might not be the only thing. You'll kind of like as you progress, okay, into this side of ML, this side of ML, you'll see that even from the infrastructure side of things, there is a lot more happening apart from just the models that are being developed. So with that, I kind of like end up my talk. Happy to answer any questions that can like kind of come up. But otherwise, like these are my credentials. You can reach out to me on LinkedIn. Just search for Dharmesh Vaya, or on Twitter at the DRVAYA. And if I can just have a one-liner, I work at Agraya Technologies. We are a GCP partner. We build like different solutions across different businesses, specifically in terms of cloud platforms. We are like more of like platform agnostic, but heavily onto integrated onto the GCP side. So you can reach out agraya.com/cloud. And a small shameless plug of like 2 seconds. Please also register on the DevFest India website. It's coming up in the next month or so, like almost like 40 days remaining. It's like in between 16th to 18th October. Please do register over that website, and you'll get to know a lot happening around like cloud, mobile, even machine learning is a part of that. So yeah, that's it from my side, and happy to like kind of take up some questions.
Thank you so much, Ramesh. An awesome slide and awesome presentation. It really gave the information of the both the worlds from DevOps perspective, from ML perspective, and deployment perspective. So we'll take one question. Okay.
Yeah. Sure.
So there is one question from Ajita, and it
Yeah.
says, could you tell us where I can learn easily TFX? Yeah,
Okay.
so that was the question. Where you can learn about TFX easily?
Okay. So
Website
see,
tutorials or
basically,
books if you recommend something. Yeah, a
well, I
website
would.
tutorials or book.
Yes, I would specifically recommend, attending first of all these kind of summits and sessions. You'll get to have a good quick start on what exactly you should be proceeding about. Okay, but then ideally, I would rather, since this is a lot of a new domain as such which is being explored. Okay, I would prefer that you go ahead and refer to the tensorflow.org websites. Okay, there is a lot of tutorials and documentation available over there. Okay, and you would I'm sure like you will find tons of resources over there, as well as if you go into the GCP community website. Okay, there is a cloud community within the GCP website itself. So if you go to cloud.google.com /communities, I believe, you will find a lot of tutorials around deploying ML models or deploying any kind of ML applications over there. So you'll find a ton of resources within the GCP domain itself.
Thank you so much, Dharmesh. That was really informative. Um,
Thank you.
yeah, thank you so much for coming and enlightening our audience. Thank you so much.
Thank you so much, Ali. It was a pleasure being a part of TFUG India. Pleasure is all. Thank you so much.
Thank you. Okay.
All right.
So the next up we have is a project showcase, a community project showcase. So today we have a project showcase about smart waste segregation system, and for that we have presenters Ashi and Anuj. So I guess Ashi is present here. She will share about her project. I welcome you, Ashi. Um,
Thank you. Thank you, Ali. I hope you can hear
you
me.
can share. Yes, I can hear you. You can share your screen, and we can get started. Thank you so much. Yeah.
So, is my screen visible to you all? I hope it is. So, thank you so much for inviting us. My name is Ashi, and I am an undergrad student pursuing electronics and communication engineering. And I'm here to present my project, Smart Waste Segregation System, using artificial intelligence, which I made with my brother Anuj. So, without a further ado, let's get started with the project video. Okay. This presentation is identifying the problem, what solution we are proposing, and what's next in this project for you. So, according to Global Waste Index 2019, our global waste production is predicted to rise by 70%, and that is by 2050. And the main issue is going to be waste segregation. So, that's the main problem. So, do you think the waste is actually the problem? In my concern, no, it is not. But waste management is a very, very big problem when it comes to mixed waste. Because mixed waste it cannot be reused and is usually dumped into landfills. There is no system for waste segregation at the sources like our houses, our schools, our offices. If you don't think that this is a serious problem, have a look at this image. It will tell you how mountainous this problem is. If you ever have visited Delhi, you can see on the outer skirts of Delhi a huge mountain. Don't worry, it's not a hill station, but it is the accumulation of waste. So, is there any solution to this problem? Yes, it is. We have made a system which uses computer vision to determine whether a waste is biodegradable or non-biodegradable. How we achieved it? There are simple 4 steps. First, data collection. For this, we used Google Images. Second is machine learning model that we trained the data on. And third, after the model is trained, we deployed it using TensorFlow Lite and for Android and iOS. And finally, we integrated all these using hardware, that is ESP8266 and servo motors. We'll get to them one by one. So, data collection. For data collection, we used Google Images, and there was basically 2 classes. One was the biodegradable, and the other was the non-biodegradable one. For both of the classes, we had 4 labels, like leaf waste, food waste, paper waste, and wood waste. And similar for the non-biodegradable waste. Then, we divided this data into trained and test sets. For the machine learning model, we use transfer learning and fine-tune the final last layers of the pre-trained models. For this, we use Inception, ResNet, and MobileNet models for doing the training. Due to trade-off between the test and accuracy as well as the model size, we went off with MobileNet having the test accuracy of 96.25%. Here are some sample predictions from our model. For mobile development, we quantize the model by 8-bit quantization. This is done so that we can fit the trained model into our mobile phones, that is the Android, and convert it into TF Lite. Then we developed an Android application that captures the image and gives the image to the TF Lite model, which performs the inference. After the inference is done, the app displays the model prediction label as well as the confidence score. So enough of the software. For the hardware, our core focus was on the communication module, which is done using this ESP8266, also known as Node MCU board. It is famous for its Wi-Fi chip on board. It is quite easy to use and is Arduino IDE capable. So it's pretty cheap and coding it is very easy. So all hardware and all software was brought together and we got this. The system architecture. So as you saw in the demo video, there was a camera which took the image. We did some pre-processing on the image like shaping it, resizing. Then we gave the image to the model for inference and got the inference result. Then we gave the model results to the communication module, that is our ESP8266, and then from that it goes to the control module or say servo motors to lift up the bin lids up and down. Here is an end-to-end working example. Say you have a plastic bottle, you capture the image of the bottle from the camera, it pre-processes it and gives the image to the machine learning model for inference. The machine learning model inferred the result that it was a non-biodegradable waste. Over the Wi-Fi, it sends this result to the Node MCU, which is the main controller for servo motors. ESP tells servo motors that, okay, this is the instruction to open or move the motor to lid up the non-biodegradable waste bin, and it opens up. Gradually, after a delay, the bin will close down itself. Here is a final Android application. It is a pretty simple one. So it gives us the type of waste, the subclass of the waste, like plastic bottle, and the status of both lids, whether which lid is open, which lid is closed, and if both are closed, it will give off. Finally, keeping it short, Coming to the future steps, we're trying to add more classes to cover some edge cases and also trying to do federated learning so that we compress the model into a low power embedded system and deploy it over that. Say, deploying this model on an Arduino Nano or maybe a Raspberry Pi with a camera module. Finally, we're developing a cloud based interface to help local authorities figure out when a dustbin is full and it gives them a ping to clean it up and makes the waste management thing more efficient. Finally, I take this opportunity to thank the TFUG community and all the presenters as well as the organizers to having us here. You can always connect with us on Twitter, GitHub, YouTube, and blog. Do reach out to us and have a look at the code on my GitHub, and there will be a repository called Smart Waste Segregation System. Finally, a big thank you for letting us display our project here. Thank you.
Thank you so much, Ashi. It was a wonderful project, and I really hope our audience loved it. I really loved it personally, and it does solve a major problem in the society. So, thank you so much, Ashi, for sharing your insights and your project. Please, guys, do check out the GitHub repository and maybe contribute if you can. So, yeah, that is awesome. Okay, so before we end this talk, I hope you guys have filled the feedback form. And if you have already, that is amazing. If you haven't yet got the chance, the link is right there. Go up there, hit that button, and fill the feedback form. Did you know that you get an e-certificate once you fill that form? Okay, I just told you the secret. So yeah, please fill it up, and then you can get an e-certificate as soon as possible. Thank you so much, everyone, for tuning in today and making it a successful day. And we would love to see you tomorrow again for the last day of TFUG India Summit. Thank you very much. Have a good day. Bye bye. Take care.